All right, AP Stats students, this is 1.3. This is all stuff in this chapter you should have seen before. There's one thing that I'm not so sure about, and that's the standard deviation. That's what we're going to do last. We're going to do some class activities to take care of that. So let's start with the mean. You know, another word for mean is average. The Jameson family drove through 7 states on their summer vacation. Gas prices varied from state to state. So what we're going to do is we're going to add them all up and divide by how many that you have. That's what this means, sum of I. So 1.79 plus 1.61 plus 2.11. So 7 states. So this population versus sample is going to be an important idea later. Again, this is a sample of them, so we call it X bar. So this is the mean of the sample. If we had every gas price from all of the states, we could use this mu, which is the population mean. Both X bar and mu mean mean. So here's what it looks like on the calculator. Notice how I added all of them up and then divided them all by 7. Again, you press Control Divide on your calculator to do that. And I can show you that in class. But make sure that you are going through these motions. Remember, you need to do the calculations. You can't just watch me do the calculations or you're not going to know how to do them. So rounding, this would be 1.88. So my mean would be $1.88. For the median, you can put the numbers in order and then cross them off until you reach the center. And then there's this even odd. If it's odd, you just take the middle number. If it's even, there will be 2 middle numbers, so you just take the mean of those 2. So another word for median is middle. All right, so I've got all my numbers in order, and I'm just going to cross them off one at a time. One from each side. You could do this another way where you just kind of look at the middle. This was an odd one, so we just have one number in the middle, 1.84. Our median is $1.84. If there was 2, then we would have averaged those. So we would have done 1.84 plus 1.96 divided by 2, and that would have been our median, but that's not the case. Now we have box and whisker plots. So make and interpret a box and whisker plot from the following data. The following data represents a number of text messages sent in the last 24 hours from Mr. Bloom's AP Stats class. So we have all these numbers that are not in order. We need to find the 5-number summary, so we're going to put the data in order first. All right, so now that my data is all in order, I'm going to start off with my whiskers. I have the smallest number, the minimum, which is 0. I have my maximum as well, which is my other whisker. My maximum was 118. And I have 26 different data points. So what I need is the middle 2 numbers because it's even. So that's at 13. So the 13 and the 14 are my middle 2 numbers, and that's going to help me find my median. So 8 and 9, what I'm going to do is I add them up and find their average, which is 8.5. So my median is 8.5. Remember, you only have to do that if it's even. And then I'm going to split my data in half from there to find my quartiles. This is my first quartile, and this is my third quartile. So since I have 13, I just need my middle number, which will be 7, which is 3, and 7 from here, which is 42. So here's a little note on here. That's the first quartile is called Q1 a lot, and the third quartile is called Q3. So this median is actually called Q2. It's the second quarter of the data, right? Which is really half, right? 2 quarters is a half. So hopefully that'll help you make some sense of it, because here's a quarter of data, here's a quarter of data, here's a quarter of data, here's a quarter of data. That's what these quartiles are doing. Okay, my interquartile range is the same as like range. You take the max minus the min, but we're doing that with quartiles. So we take Q3 minus Q1. So 42 minus 3. So our interquartile range is 39. Now we're going to graph all this on our number line. So we're going all the way up to 118. So I'm going to count by tens. So I cheated it a little, but that's okay. So here's my whiskers at 0 and at 118. Doesn't have to be perfect. And then I have my quartiles. So I have 3, 8.5, and 42. So there's my box, and these are my whiskers. It's rarely going to be called a box and whisker plot. We just call it a box plot. Okay? So if we were to describe this, we would use our socks, our shape. Well, you can see that it's not, this box is not in the middle. There's a huge skew. It's very skewed right. So that was our shape. Outliers, we have possible outliers and a gap here, right? There's still some values, so I'm not sure if we would want to call it a gap or just outliers. I'm going to come back to that in a second. The center, again, we have a median, so we're going to use that as our median. We'd say the median is 8.5. And our spread, we can use IQR for our spread. We could use range for our spread. I'm going to use IQR. The IQR is 39. IQR is talking about where the middle half of our data, remember from the third and first quartile, that's half of our data is 39 wide. What's nice about the IQR is that we don't have to worry about if these outliers are in there. The range has the outliers in it, but the IQR is very resistant to that. Okay, standard deviation is going to be affected by these outliers as well. Okay, so that's good for now. So here's the formal definition of an outlier. If an observation falls 1.5 times the IQR above the third quartile or below the first quartile. So first of all, we need to know what 1.5 times the IQR is. 1.5 times 39. It's 58.5. So above the third quartile or below the first quartile. So I'm going to take my third quartile of 42, and I'm saying above the third quartile, so plus that 1.5 times the IQR, so plus the 58.5. So this is 100.5. This is the threshold. Now, if there's a number above this 1.5 times the IQR above the third quartile, then it's considered an outlier. So if we go back to our data, we have 118 is considered an outlier. So this 118 we would put as a dot on here, and then we would actually cut our whisker off here at 98. So there is an official outlier. So 118 is an outlier. That was just above, so let's check the below. So if we said 1.5 times the IQR below the first quartile, well, the first quartile is at 3, so we would say 3 minus 58.5. Well, that's negative 55-ish. There's nothing past that, okay? Because this is, again, this is a threshold. If it's above this 1.5 times the IQR, above the third quartile, if it's past this, it's an outlier, or if it's past this in the negative sense, so it's really going this way, then that would also be an outlier. So we don't have any low outliers. Okay, so remember this. Now we're going to talk about variance and standard deviation. Okay, so there are some complicated formulas. I have an activity that's going to make these make a little bit more sense in class, so hopefully that'll help out. Our standard deviation is basically the same. However, we take the square root of the variance. You see how this is the variance? Well, we just take the square root of all of that. Now let's make some sense out of all of these things. Okay, so we have x1, that's an observation. And this, remember, x bar means mean. So we see how far away something is from the mean and square it. We do the same thing with our next observation. How far away is it from the mean? And then square it. And we keep doing that until we have all of them. And then we divide by n minus 1. The n minus 1, we're not going to worry too much about that for now. We're going to use it. So here we go. Find and interpret the variance and the standard deviation. Okay, so I've got my variance. And then I have my standard deviation, S of x. Okay, that's a notation that we're going to learn about, so don't worry too much about that right now. We're just getting a feel for it. So the first thing we need is the mean. So I'm going to take my foot lengths from 14-year-olds from the UK, and I'm going to find the mean using my calculator. So I'm going to add them all up and divide by 7, because there's 7 of these. So there we go. That's our mean of 24. So what we're going to do for this variance, remember, we're going to take our first value minus the mean. So our first value is 25 minus the mean of 24, and then we're going to square it. Then we're going to add up our next one. We have 22 minus our mean of 24, square it. Then we got our next one. All until we take our last value of 28 minus the mean of 24 and square it, and we divide all of that by n minus 1. So n was 7, so 7 minus 1, so 6. I'm going to plug all of that into my calculator. So there's what it all looks like. Make sure that you do all of this on your own. Make sure that you get practice typing it in. It will only help you. So there is my variance. Make sure that you type all of that in. I get a fraction and I want to make it a decimal. I can hit Control Enter, which I don't have on my keypad, or I could just add a decimal. If I put a decimal into the problem, I get a decimal out of the problem. So 6.33. So my variance is 6.33, and my standard deviation is the square root of that. I just take the square root of all that. So there's my standard deviation, 2.52. So there's my standard deviation. When I interpret the standard deviation, it's very, very important. The foot lengths vary from the mean by an average of 2.52 centimeters. Okay, so the average foot length for 14-year-olds from the UK vary from the mean by an average of 2.52 centimeters. Okay, now calculators are absolutely amazing. You need to know how to do this by hand, but more importantly, you need to know how to do it by calculator. You're going to use it a lot. So let me show you how to do all that. You need a lists and spreadsheets page. So I have a list and spreadsheets page. I'm going to call this foot length because I can. Then I'm going to put all my foot lengths in. Now that I have all these, I'm going to add a data and statistics page just to show you what distribution is going to look like. Now that doesn't matter as much. What I really need is a calculator page. On this calculator page, you're going to click Menu. I don't have that on here. You have to be able to find it by yourself. Statistics, Stat Calcs, one variable stats. And we're going to use that foot length. So remember all of that stuff. Our mean was 24, like I said. The standard deviation, there's that 2.51, and our number was 7. There's the 5-number summary: min, the first quartile, the second quartile, the median, the third quartile, and the max. So there's a lot of stuff all done for you, which is super duper nice. Okay, so make sure that you're using your calculator. You need to know how to do this one. I would 100% recommend that you do this right now. We're going to do it in class too, but the more that you do these one variable stats, the better. One more quick question. Why would it make sense to use IQR over standard deviation? Well, remember how the standard deviation uses every single value? Well, we could have those outliers. Remember our last example where we had all these outliers? Well, that outlier is going to be included in the standard deviation. The IQR is resistant